Hello, beautiful math people. We are going to do Chapter 6, Section 3, and this is called elimination. So yesterday you did substitution, and today is something totally different, and I think my board is fixed, so this is going to be so fantastic. All right, if you have two equations in standard form, then you could do what you did yesterday, which is solve for a letter, plug it in and substitute. But if the two equations are written like this, it's way easier to do something called elimination. So we're going to draw a line, and the goal is to eliminate one of the letters. So if you look at this A, the first two A's, this one right here and this one right here, they are the same. So if you subtract them, 2A minus 2A is 0A. So 0A, we don't even need to write that. It's like nothing. It doesn't even need to be there. I'm going to erase it. It's 0. Gone. Goodbye. Okay. So we're going to subtract everything. 4C minus 2C is 2C, and then an equals sign, and then 30 minus 21.5 is 8.5. So 2C equals 8.5. Solve for C by dividing by 2. So C equals 4.25. Now we're going to plug that back into either of the original, whichever one you prefer. I'm thinking if you plug it into the top one, you won't have a decimal, so that might be the easier one. 2A plus 4 times 4 1/4, 4.25 is 4 1/4, equals 30. So 2A plus 17, 4 times 4 is 16, 4 times 1/4 is 1, equals 30. And then subtract 17, whoa. So 2A equals 13. And A is 6.5. Now, a really good way to test yourself is to plug it into the other equation as well and make sure you get 6.5. So 2A plus 2 times 4 1/4 equals 21.5. So 2A plus 8 1/2 equals 21.5. So when you minus 8 1/2, so 2A equals 12, 13, and then divided by 2 is 6.5. Perfect. So both of them got 6.5. So you can be 100% certain that your ordered pair solution is 6.5 for the A and then 4.25 for the B. So this point is where these two things cross. Elimination. Line them up and either add or subtract to get rid of one of the letters, because you want to have two equations with one letter so that you can solve for that. So we're going to do another problem. 3x minus 2y equals -4, and 4x plus 2y equals 10. So this time, the letter that can be eliminated is the y here. See how they're both a 2y? And the very first one, if you slash and dash, is a negative. You might see that with the minus and not have to do that. So we can just add this time to eliminate. -3x plus 4x is 1x. The y's cancel, and -4 plus 10 is 6. So x equals 6. Now you're going to plug 6 into one of the original. I'm going to plug it into both of the originals just to make sure I have the right answer. So -3 times 6 minus 2y equals -4. So -18 minus 2y is equal to -4. Add 18 to both sides. So -2y is equal to 14, so y is equal to -7. Just to make sure, plugging it into this one as well. 4 times 6 plus 2y equals 10. So 24 plus 2y equals 10. subtract 24, so 2y is negative 14, and yes, you get negative 7 as well. So the ordered pair solution here is 6, negative 7, and for sure that's right. That's the x and the y. That's the point where they cross. So this elimination, substitution, graphing, all of these are just solving the point where they cross. I'm going to give you a little story problem. The sum of two numbers is 27. So right now you could write x plus y equals 27. And the difference is 5. So x minus y equals 5. All right, you could add, and then you are eliminating the y. So you get 2x equals 7. So x is equal to 3.5. I'm actually going to rewrite the equations and also subtract. And subtracting will eliminate the x. So if you subtract, x minus x is 0, y minus negative y is 2y, and 2 minus negative 5 is negative 3. So y is equal to negative 1.5. This time you don't have to plug something in because we actually solved both ways. So the ordered pair solution is 3.5 and then negative 1.5, like so. So sometimes when you have the two things lined up, the letter does not have the same coefficient. So in that case, you would need to make it the same coefficient by multiplying or dividing everything in one of the equations. So if you look at this lovely new situation, hopefully you're noticing that it would be pretty easy to get the ends to be the same if you just multiplied this by 2. And in fact, if you multiply by negative 2, you could actually add to eliminate instead of subtract. It doesn't matter if you add or subtract, it'll give you the same exact thing. So negative 150p plus negative 60n equals negative 80. And then the other equation we're just going to keep the same, which is 50p plus 60n equals 35. So we're going to add to eliminate because these coefficients are the opposite signage so that when you add, they cancel each other out and get 0. Again, if you multiplied by just a positive 2, you would be subtracting to eliminate. So when you add the p's, you get a negative 100p, the n's cancel, and 35 plus negative 85 is negative 45. So we're going to divide by negative 100, and p is equal to 45 over 100, which is 0.45, or you could reduce the fraction. 45 over 100, oh my, 5 goes into both of those, so that's 9 over 20. Either way is wonderful. So you have the p. You still need to solve for n. So you're going to plug the p into one of the original equations. We'll go right there. So 50 times 0.45 plus 60n equals 35. So 50 times 0.45, I'm going to put the 0 as the placeholder. 5 times 5 is 25. 5 times 4 is 20, plus 2 is 22. There are 2 decimals in the initial problem, so there should be 2 decimals in the answer. I'm not going to put the 0, but that 0 is the other decimal placeholder. This does make sense that it's 22.5 because half of 50 is 25, and we're finding 45% of it, which is a little less. So to solve for n, you would subtract 22.5. So you have 12.5 equaling n. Whoa, hold on, 60n. Divide both sides by 60, and since the bell's ringing, I have no idea what that is, grabbing a calculator. 12.5 divided by 60 is 0.2. So your ordered pair solution is 0.2. You should put the n first, MNOP, and then 0.45. And you can plug that in and test that it works. All right, well, that is a quick explanation of elimination. We will do some more tomorrow. Have a lovely evening.